This is worksheet 16.4, which is a review of the exponent concepts so far. On this first section, we're simplifying each expression. All of these expressions have radicals, and we'll look at different ways of simplifying these. So on number 1, here we're doing cube root of 27 to the 4th. First, we can check whether we can simplify the cube root of 27. So cube root of 27 is 3, and then you're raising that to the 4th. So 3 to the 4th is equal to 81. And we'll cross that out in the answer bank. On number 2, we have 6th root of 64. If you're not sure what the 6th root of 64 is, I'll also show you another way of doing this problem. If you can recognize that 2 times itself 6 times is 64, you can say 6th root of 64 is 2, and then you're cubing that. So 2 to the 3rd is 8. Another way of approaching this problem is to change this from radical form to exponential form. If you do that, the base is 64. The exponent has a denominator of 6 and a numerator of 3. So that would be 3 over 6. 3 over 6 is the same as 1/2. So this is 64 to the 1/2, which is equivalent to the square root of 8. Or, oops, that should be square root of 64 to the first power. So square root of 64 is 8 to the first power. Alright, on number 5, 5th root of 32, what number times itself 5 times gives you 32? That would be 2. Alright, on number 8, if you try starting by doing 4th root of 9, that's not easy to figure out. That's going to be some decimal. So instead of trying to do 4th root of 9, I'm going to change this to exponential form. So the 4 is the denominator of the fraction in the exponent. The 6 is the numerator. 9 to the 6 over 4, that's the same as 9 to the 3 over 2, which gives you square root of 9 and then cubed. Square root of 9 is 3. 3 to the 3rd is 27. A quick way of doing that, if you just want to go straight to exponential form that we got here, is the two numbers here can be reduced. So if you look at the 4 and the 6, you can reduce it to 3 and 2. So you have square root of 9 cubed, which is what we just did right here.